Hello learners, you are welcome in the studio of National Institute of Open Schooling. Myself is Dr. Kusum Bhatia. Today I am going to teach you exponential notations. Let us see whether these laws hold good if m and n are negative integers. You know reciprocal of 2 is 1 by 2. You know reciprocal of 3 is 1 by 3. And 1 by 2 can be written as 2 raised to power minus 1. Reciprocal of 2 square is 1 by 2 square, which can be written as 2 raised to power minus 2. Reciprocal of minus 7 raised to power 3 is 1 upon minus 7 to the power 3 or minus 7 raised to power minus 3. If a is any non-zero rational number and m is any positive integer, then reciprocal of a raised to power m is 1 upon a raised to power m, or if you write it in the numerator, then it is a raised to power minus m. So, we learn two things here, that reciprocal of a raised to power m is 1 upon a raised to power m, and 1 upon a raised to power m can be written as a raised to power minus m. So, reciprocal of 5 is 1 by 5, reciprocal of 1 by 2 is 2. Let us find the reciprocal of 2 by 3 raised to power minus 7. 2 by 3 raised to power minus 7, mind it, the power is negative. So, for making this power positive, you will write this number in the denominator. So, it will be 1 upon 2 by 3 raised to power 7. It is equal to 1 upon 2 raised to power 7 divided by 3 raised to power 7, and it will come in the numerator 3 raised to power 7 divided by 2 raised to power 7, which is equal to 3 by 2 raised to power 7. This example gives us if p by q is any non-zero rational number and m is a positive integer, then p by q raised to power minus m is equal to q by p raised to power m. Laws of exponents for integral exponents. Let us see whether these laws of exponents hold good for m and n to be negative exponents. First of all, we take one example where we take m and n as negative integers. For example, 3 raised to power minus 2 multiplied by 3 raised to power minus 3. Here what is a, or what is the base of the exponent? It is 3. And what are the powers? Powers are minus 2 and minus 3, or you can say m is minus 2 and n is minus 3. 3 raised to power minus 2 can be written as 1 by 3 square, and 3 raised to power minus 3 can be written as 1 by 3 cube. So, this expression is equal to 1 by 3 square multiplied by 1 by 3 cube, which is equal to 1 upon 3 raised to power 2 plus 3, or in the numerator you can write 3 raised to power minus 2 minus 3, which is equal to 3 raised to power minus 2 multiplied by 3 raised to power minus 3, which is equal to 3 raised to power minus 2 minus 3. That is, if a raised to power m is multiplied to a raised to power n, this is equal to a raised to power m plus n, hold good when m and n are negative integers. Now, let us take second case where m is greater than n and we are dividing the two numbers with same bases and with negative powers. For example, 3 raised to power minus 2 divided by 3 raised to power minus 3. Here what is m? M is minus 2. What is n? N is minus 3 and m is greater than n. So, 3 raised to power minus 2 is equal to 1 by 3 square and 3 raised to power minus 3 is equal to 1 upon 3 cube. So, we are writing 1 by 3 square divided by 1 by 3 cube, which is equal to 1 by 3 square, and division sign is replaced by multiplication sign, and we write the reciprocal of the number, which gives you 3 raised to power 3 minus 2, which is equal to 3, or you can say it is equal to 3 raised to power m minus n. So, the result hold good if m and n are negative integers. Now, take the second example where 3 raised to the power minus 2 divided by 3 raised to the power minus 3 is equal to 3 raised to the power minus 2 plus 3. If m is equal to minus 2 and n is equal to minus 3 and m is greater than n, it is equal to 3 raised to the power m minus n. That means a raised to the power m divided by a raised to the power n is equal to a raised to the power m minus n hold good if m and n are negative integers and certainly m is greater than n. Let us evaluate 1 by 2 raised to the power minus 2 whole to the power 3. This example will give us the third law of exponent for n to be a negative integer. Now, 1 by 2 raised to the power minus 2 can be written as 2 by 1 whole to the power 2 and this is whole to the power 3. So, this is 2 by 1 into 2 by 1 into 2 by 1 how many times? 6 times, which can be written as 2 by 1 raised to the power 6 and you can write it as instead of 2 by 1 you can take reciprocal of 2 by 1 which is 1 by 2 and in that case the power will be negative. So, this is 1 by 2 raised to the power minus 6 or you can write it as 1 by 2 raised to the power minus 2 into 3. That means a raised to the power m whole to the power n is equal to a raised to the power m into n hold good if m is a negative integer. So, we can say that all the laws of exponent hold good if a is a non-zero rational number and m and n are integers, not necessarily negative integers or not necessarily positive integers. Now, let us take the meaning of a raised to power p by q. We know that a raised to power m multiplied by a raised to power n is equal to a raised to power m plus n. A raised to power 1 by q. What is the meaning of a raised to power 1 by q? If we write a raised to power 1 by q, q times, it is a raised to power 1 by q into a raised to power 1 by q into a raised to power 1 by q, q times, it is a raised to power 1 by q multiplied by q which is equal to a. That means qth power of a raised to power 1 by q is a, or you can say qth root of a is a raised to power 1 by q. Let us see one example. 7 raised to power 1 by 4 multiplied by 7 raised to power 1 by 4 multiplied by 7 raised to power 1 by 4 multiplied by 7 raised to power 1 by 4 4 times. This is equal to 7 raised to power 1 by 4 multiplied by 4 which is equal to 7 raised to power 1 by 4 into 4 which is 7. Fourth root of 7. This is called fourth root of 7 because 7 raised to power 1 by 4 multiplied by 4 gives you 7. Now, observe one thing here that while writing the fourth power of 7, we write 4 somewhat smaller than 7. We do not write 4 equal to 7. The size of 4 is somewhat smaller than 7 and not 4 root 7. It is written as 4 under root 7. 7 raised to power 2 by 3. What is the meaning of 7 raised to power 2 by 3? It means cube root of 7 square. Likewise, 3 raised to power 4 by 7. What is the meaning of 3 raised to power 4 by 7? 3 raised to power 4 by 7 you can write as 7th root of 3 raised to power 4. That means, if a is a positive real number and p is an integer and q is a natural number, then a raised to power p by q is the qth root of a raised to power p. That is qth root of a raised to power p. Now, if you have 625 raised to power 1 by 4, what is the meaning of this? It means you write 625 in the form of prime factorization. It is 5 into 5 into 5 into 5 whole raised to power 1 by 4 and this is equal to 5 raised to power 4 whole to the power 1 by 4 and on simplification you will get 5. So, learners, today we write a given number in the exponential form. We explore the number given in the exponential form in the simplified form. We find the laws of exponents. Today we have learned the laws of exponents and to write a given number in the exponential form. If you have any difficulty in the topics which we have done today, you can contact us or you can call us on the numbers which you are seeing on the screen.
जीवन ये प्रकाशित करने, राहों को आलोकित करने, हम अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने।
सीमा से विद्यालय जो मुक्त हो, धन साधन समय की सीमा से विद्यालय जो मुक्त हो।
कभी पढ़े हम कहीं पढ़े, वे विषय की लोच से युक्त हो। मित्रों हम उठे और जागे,
हिंदुस्तान के हर कोने में नौजवानों के पास प्रतिभा है, उन्हें अवसर चाहिए।
NIOS देता रहा है युवाओं को अवसर आगे बढ़ने का। NIOS से पढ़ने वाले इन युवाओं ने किया है संस्थान को गौरवान्वित। दिव्यांगों ने बन के दिखाया है सबल और आत्मनिर्भर। NIOS के साथ आप भी जुड़िए NIOS के संग।
In the last lesson from exponent and surds, you learned about the exponential notation, how we can write a given number in exponential form, and we learned how to express the given expression in exponential form. Today we are going to learn about surds. Surds are also called radicals. You know irrational numbers, that √3, √5, √7 are irrational numbers, and irrational numbers of some particular type are called surds. Now, how you can define a surd? A surd may be defined as a positive irrational number of the type nth root of x, where x is a rational number whose nth root is not defined. In nth root of x, n is called the index of the surd and the sign is called the radical sign. Nth root of x is an irrational number. Mind it, that it should not be a rational number. That means the nth root of x may not be defined. If it is defined, if it is a rational number, then nth root of x is not a surd, and x is called the radicand in this expression. Let us see some of the examples where the given expression is a surd or it is not a surd. Example 1, cube root of 27. It may be called third root of 27 also. You know that 27 can be written as 3 into 3 into 3 3 times, because 3 3s are 9 and 9 3s are 27. Therefore, 27 you can write as 3 cube. Now, when you have given cube root of 27, it can be written as cube root of 3 to the power 3, which is equal to 3, and you know very well that 3 is not an irrational number, it is a rational number, and from the definition of the surds you can say that cube root of 27 is not a surd. Let us take second example where we have given square root of 5 plus under root 5. Now, square root of 5 plus under root 5 is an irrational number. Therefore, it is a square root of irrational number and not a rational number. So, it is not a surd. Note one thing here, that if in case order of the surd is not given, you have given surds like root 5 and root 6. Now, no order of the surd is mentioned here. In that case, we take the order of the surd as 2, because it is 2 root 5 and 2 root 6. Instead of writing 2, we sometimes write root 5 and root 6 without mentioning 2. So, if the order of the surd is not mentioned, it is taken as 2. Now, let us discuss what are pure surds and what are mixed surds. If a surd is given to you like fifth root of 16, do you know what are the factors of fifth root of 16? It has two factors. One is the 1 and the other is the irrational number. You know very well that 1 is the factor of every number. Therefore, one must factor of each surd, whether it is pure or it is mixed, and the other number is irrational number. So, the surd which have only two factors, one is the 1 and the other is the irrational factor, is called pure surd. But if you have a surd like 2 root 3, it has three factors, one is 1, the other is 2 and the third is irrational number. Surds which have more than two factors, or you can say surds which have factors other than 1 and the irrational number, are called mixed surds. Now, let us define what is the order of a surd. In 5 cube root of 4, the order of the surd is 3, because it is cube root of 4. And what is 5? 5 is called the coefficient of the surd in this surd. In surd 2 cube root of 7, 2 is called the coefficient of the surd and 3 is called the order of the surd, because we are dealing with cube root of 7. Let us discuss laws of radicals. These laws are without proof, but we use them in solving problems on radicals. First law is nth root of a whole to the power n is equal to a. Second law of radical says nth root of a multiplied by nth root of b is equal to nth root of a multiplied by b or nth root of ab. Third law of radical says nth root of a divided by nth root of b is equal to nth root of a by b. Let us check which of the products are surds. Now, here we will use the laws of radicals which we have seen just now. Example 1 is root 2 multiplied by root 18. Now, here we have two surds, one is root 2 and the other is root 18. Using the first law of radicals, that nth root of a multiplied by nth root of b is equal to nth root of ab, we can solve it. Here we have second root of 2 and second root of 18, which is equal to second root of 2 multiplied by 18, which is second root of 36, or you can say under root 36, which is equal to 6. And this 6 is a rational number, it is not an irrational number. Therefore, you can say that root 2 into root 18 is not a surd. Let us see the second example, 2 root 15 divided by 4 root 10. We can write it as 2 root 15 divided by 4 root 10. Here in the numerator you have 2 and in the denominator you have 4. And what is the highest common factor between 2 and 4? Yes, you know it very well. 2 is a common factor between 2 and 4. Therefore, we can divide numerator and denominator by 2. Dividing the numerator and denominator by 2, you will get root 15 divided by 2 root 10. Now, in the numerator you have root 15, in the denominator you have 2 root 10. You can take 2 inside the root by writing under root 2 into 10, which will give you under root 15 upon 40. Now, in the under root you have 15 and 40, and you know that 5 is the highest common factor between 15 and 40. So, we can divide numerator and denominator by 5. So, dividing the numerator and denominator by 5, you will get under root 3 by 8, which is an irrational number. And from the definition of this surd, you can say that it is a surd because under root 3 by 8 is an irrational number. Now, let us see the laws of radicals which we have learned just now can also be written as in the following manner, which is called laws of surds. Nth root of x into nth root of y is equal to x y raised to power 1 by n. Second, nth root of x divided by nth root of y is equal to x by y raised to power 1 by n. Laws of surds, third says mth root of nth root of x is equal to x to the power 1 by m whole to the power 1 by n. Fourth law says nth root of x to the power m is equal to x to the power m upon n. And the fifth law says nth root of x to the power p is equal to x to the power pn whole to the power 1 upon mn. Now, you observe one thing here, that law fifth is very important, because it says that you can change the order of the surd. The order of the surd can be changed by multiplying the index of the surd and the index of the radicand by the same positive number. Look at the fifth law once again, which is nth root of x to the power p is equal to x to the power pn whole to the power 1 upon mn. Now, note one thing here, that the index of the surd in this law is n and the index of the radicand is p. We are multiplying the order of the surd by m, where m is a positive number. At the same time, we are multiplying the index of the radicand by the same number n. Therefore, nth root of x to the power p can be written as x to the power pm whole to the power 1 upon mn, which can be written as that the order of a surd can be changed by multiplying the index of a surd and index of the radicand by the same positive number. We will use this law in many of the examples. Example first is cube root of 5. Here the index of the surd is 3 and the index of the radicand is 1. If I multiply the index of the surd by 2, that is 3 multiplied by 2, So, the index of the radicand will also be multiplied by the same number 2 here. So, it will be 6 outside and inside you will have 5 raised to power 2, which is equal to 5 into 5 or 25. Therefore, third square root of 5 can be written as 6 root 25. Let us see one more example. Fourth root of 3. Here the index of the surd is 4 and the index of the radicand is 1 because the power of 3 is 1. Now, if I want to change the order of the surd, I will multiply the index of the radicand and the index of the surd by the same number. Suppose instead of 5, I multiply 4 by 2 and I get 8th root of 3. For writing 8 root of 3, I will have to multiply the index of the radicand by the number 2 because I am multiplying the index of the surd by 2. Therefore, it will be 8th root of 3 square, which is 8th root of 3 into 3 or 8th root of 9. Let us discuss now what are similar or like surds. You know about similar fractions or like fractions, like decimals. In the same way, we have like or similar surds. Two surds are said to be similar if they can be reduced to same irrational factor. For example, you have 3 root 5 and 7 root 5. 3 root 5 is a surd, 7 root 5 is a surd, and both the surds have same irrational factor. What is that? Root 5. Next, let us see the second example, root 75 and root 12. Now, note one thing here that in 3 root 5 and 7 root 5, you can see and say that these two surds are like surds. But in case of root 75 and root 12, you have to reduce them and check them whether they are similar surds or not. Let us write 75 as 25 into 3. This under root 25 can be written as 5. Therefore, under root 25 into 3 is equal to 5 root 3, and under root 12 can be written as under root 4 into 3, and the square root of 4 is 2. Therefore, it is equal to 2 root 3. Now, look at the two surds. Under root 75 is reduced to 5 root 3. Under root 12 is reduced to 2 root 3. Both have same irrational factor. What is that? Root 3. Therefore, these two surds are like surds. Learners, up till now we have learned what are surds, what is the order of the surd, what are the laws of radicals, and what are like and similar surds. If you have any query, you can write to us, you can call us on the numbers being flashed on the screen.